Okay, so this is a continuation of the Chapter 3-4 practice test. In this learning target, it says you can differentiate between strong, weak, and non-electrolytes, and then you'll have strong acids and strong bases memorized as well. So number 11, an electrolyte conducts electricity because it has ions in solution. Ions are positive or negative species that carry a charge. What is an electrolyte? That's one that when it dissociates, when it dissolves, it completely dissociates in water to form ions. Ions, remember, the positive and negatively charged species. What is an ion? An ion is a species that has a positive or a negative charge. So Na plus or Cl minus would be examples of ions that have dissociated and would conduct electricity. A cation is a positive ion, an anion is a negative ion, so this would be an example of a cation, this would be an example of an anion, which are soluble and which are not. So now you need to be able to use your solubility rules. So your solubility rules are located on the inside of the periodic table, and then you need to be able to read these rules and decide whether they're soluble or not. Potassium carbonate is soluble because all alkali metal cations of group 1A are soluble, and group 1A, of course, includes lithium, sodium, potassium, rubidium, and cesium right here. You might want to write them in here. Lithium, sodium, potassium, rubidium, and cesium. Write those in so then you know that, oh, those are the alkali metal cations. Sodium, once again, is an alkali metal, so it's soluble. Calcium chromate is insoluble because it's not listed anywhere on here, and it does say chromates are insoluble except for the group 1s and those few right there. Although it does give calcium chromate right here with a star on it, which means that it is slightly soluble. Usually for the slightly solubles, we pretty much say insoluble. So I get it that there's one with a star on it there. That's close. Silver nitrate is soluble because all nitrates are soluble. Ammonium sulfide. So it says that all sulfides are insoluble except for group 1, 2, and ammonia. And so this is ammonia, so it is soluble. Aluminum hydroxide is insoluble because all hydroxides are insoluble except for group 1A and the strong bases. Are all strong acids soluble? Why or why not? So yes, all strong acids are soluble, and all strong acids also completely dissociate into H plus and their anion minus. Are all strong bases soluble? Technically, yes. All these alkali and alkali earth metal hydroxides are soluble. Technically, calcium hydroxide is not super soluble, but what does dissolve is going to be completely into ions as well. But for the most part, they completely dissolve. And then, if something is soluble, does that mean it's a strong electrolyte? That answer is no. It means it would dissolve, but it doesn't mean that it's going to form cation anions. For example, C12H22O11, something called sucrose or sugar, dissolves really well in water. It's soluble, but it doesn't make any ions, and therefore it is a weak electrolyte. So just because it's soluble does not mean it's strong. What is an acid? An acid is something that donates hydrogens or protons. It makes H pluses in solution. What's a base? It's something that makes hydroxides in solution or causes OH minuses to increase in concentration. What's the definition of something that's oxidized? Oxidized is something that goes up in charge. Reduction is something that goes down in charge. So some people think of it as oil rig. Oxidation is loss of electrons, reduction is gain. Which of the following is a strong electrolyte? More than one answer or multiple answers are possible. This is a strong electrolyte. This is a non-electrolyte. This is strong, and this is strong. Strong acid, strong acid. Strong base. This is what's called a soluble ionic salt. So it's one of these in here that's made of a positive ion and a negative ion. And on here it's soluble. And then this right here is molecular. This is called methane, and it doesn't appreciate. It might dissolve a little bit in water, but it does not break up into ions. All right, next page. A solution of potassium chloride exists predominantly as ions in solution. Potassium chloride is KCl, and it would be completely soluble in water because, of course, all alkali metals are soluble, and then since it's a metal and a nonmetal and it dissolves, it completely breaks up into K pluses and Cl minuses. The key to knowing if something forms ions in solution is to know if it's ionic. If it's an ionic thing, that means it has a metal and a nonmetal, or a metal and a polyatomic ion. Then check to see if it dissolves. If it dissolves and it's soluble, then it's going to make ions in solution. All right, the next learning target is I can differentiate between different types of reactions and write them in net ionic equations. So this one right here has a base and an acid in it, so this is an acid-base reaction. This one right here has one thing and it breaks up into two or more, so this is called a decomposition type reaction. Technically, sometimes decomposition reactions are redox. I don't think this one necessarily is, but it's one that breaks up into two or more items. Number 23, this one makes a solid right here, so it's called a precipitation reaction. This one right here, you can notice that cadmium goes from 0 to positive 2. It goes up in charge, therefore it's oxidized. Silver goes from positive 1 to 0, so it goes down in charge, so it is reduced. So this is a redox or an oxidation-reduction reaction. Number 25, predict the product of the combination reaction below. So then nickel would go together with bromine, and if you said nickel is plus 2, then it would be NiBr2. What dissolved species are present in solution of K2CO3? So this is a soluble substance. If you look on here, all potassium salts are soluble. So you're going to get 2 K pluses, and you're going to get a CO3 2 minus in there. So those are the dissolved species in the solution. So that would be letter B right here. And then which element is oxidized and which is reduced in the following reaction. So you have to know how to do your assigning of oxidation numbers and look for the weak ones or the easy ones first. When they're alone by themselves, this would be 0. This one's alone by himself, it would also be 0. Remember, ignore the coefficients because they have nothing to do with assigning the oxidation numbers. Magnesium you can make a really good guess for, because magnesium is in group 2 on the periodic table, and group 2 things are almost always plus 2. This species right here, NO3, is a polyatomic ion that you memorized, and so this would have a -1 charge as a small group, NO3 right here. That means this NO3 would also have a -1 charge, which means manganese over here, since this is -1 and there's 3 of them, would have to be positive 3. So now you can tell what's oxidized and reduced because manganese goes from positive 3 down to 0. So 3 down to 0 means that it was reduced or it went down in charge. And then magnesium went from 0 up to positive 2. So going from 0 to 2 means it went up and therefore it was oxidized. We'll come back with more of this in the next video.